Hello everyone, let's start our lesson for today with this question. Can you create your own figure out of these basic shapes? You may pause the video while creating your own figure. What figures were you able to make? Some of you may have drawn a house from a square and a triangle. Or you may have drawn a house which looks like this one using a trapezoid, rectangle, and squares. Or some of you may have drawn a truck which looks like this one from rectangles, squares, and semicircles. Now, as you can see, combining two or more basic shapes will help you create a new figure. And these new figures we have on the screen are what we call as composite figures. So what are composite figures? Composite figures are figures made up of two or more basic plane figures. Sometimes it is also called an irregular figure. So these are examples of composite figures. Now, in today's lesson, we'll focus on finding the area of composite figures. And here are the steps that we need to follow. First, we break apart the composite figure into basic geometric shapes. Then we find for the area of the basic figures which make up the composite figure, and we add all the areas of those basic shapes. So let's have a short recall of the formulas for finding the area of these basic shapes. For the square, we have s squared, or side times side. For rectangle, we have length times width. For parallelogram, that is base times height. And for the triangle, we have base times height divided by 2. For the trapezoid, we have base of 1 plus base of 2 divided by 2 times height. And finally, for the circle, that is pi r squared. So let's have some examples. Let's try to find for the area of this composite figure. So as you can see, this composite figure is made up of a triangle, this one, and a semicircle. So this triangle and this semicircle is sharing a side, which is this one, okay? So this is acting as the height of the triangle and at the same time the diameter of the semicircle. Now let's find for the area of a triangle using this formula. For the base, we have 12 meters, and for the height, we have 8 meters. So we have 12 meters times 8 meters divided by 2. That is equivalent to 96 square meters divided by 2, which gives us 48 square meters for the area of the triangle. On the other hand, we know that the area of a circle is equal to pi r squared. But we have here only half of a circle, so we need to divide that area by 2. So, what we will use in our formula is pi r squared divided by 2 because again, we only have here half of a circle. Then, for the radius, since the diameter is 8 meters, we'll have the radius as 4 meters because radius is half of diameter. Substituting the given information, we'll have 3.14 times 4 meters squared divided by 2. Okay, 4 meters squared is equal to 16 square meters times 3.14 divided by 2 will give us 50.24 square meters divided by 2. And that is equal to 25.12 square meters. But we're not yet done because again, this is just the area of the semicircle. We have to add it to the area of the triangle to find for the area of this composite figure. So, adding 48 square meters and 25.12 square meters will give us 73.12 square meters. Therefore, this is the area of our composite figure. Let's have some more examples. Find for the area of this composite figure made up of a rectangle and a triangle. So again, to find for the area of a rectangle, that will be length times width. So we'll have 15 centimeters times 12 centimeters, which is equal to 180 square centimeters. Okay, that is the area of this triangle. Now for the area of the triangle, we have base times height divided by 2. Substituting the given information, we have 7 centimeters times 12 centimeters divided by 2 is equal to 84 square centimeters divided by 2, and that is equivalent to 42 square centimeters. Okay, so we have here the area of the triangle. Now, Adding the area of the rectangle and the area of the triangle will give us 222 square centimeters. Therefore, this is the area of our composite figure here. Next, okay, let's find the area of this figure. So again, we have to decompose this composite figure into its basic shapes. So we have here a triangle and a rectangle. Okay, so in a rectangle, we know that opposite sides are equal. So if this is 2 meters, it follows that this one is also 2 meters. Therefore, the base of this triangle measures 2 meters plus 2 meters plus 2 meters. That is equal to 6 meters. Then, to find for its height, we know that this composite figure is 15 meters tall. Then, the rectangle is 10 meters high. So if we subtract 15 meters and 10 meters, we'll be able to find for the height of this triangle. And that would be 15 minus 10. It's 5 meters. Now let's find for the area of the rectangle. The height again, or the length of the rectangle, is 10 meters and its width is 2 meters. So we'll have 10 meters times 2 meters. That is equal to 20 square meters. Then for the triangle, we have base times height divided by 2. So we have here 6 meters times 5 meters divided by 2 is equal to 30 square meters divided by 2, which is equivalent to 15 square meters. So if we add 20 square meters and 15 square meters, that will be equal to 35 square meters. Therefore, the area of this composite figure we have is 35 square meters. Next example, let us find the area of this composite figure here. So we can dissect or we can decompose this composite figure in different ways. We can actually get a square here. Okay. This is a square since it's given that this side is 3 centimeters and this side is also 3 centimeters. So if I cut this figure this way, it follows that this one is also 3 centimeters. Okay. Then if this is 3 centimeters, from here up to this one is also 3 centimeters. So if the height of this figure is 5 centimeters, the remaining part here will be equal to 2 centimeters. Or I can also cut this figure this way. Since we have here a rectangle, in a rectangle opposite sides are equal. So if this is 3 centimeters, it follows that this part here is also 3 centimeters. And since the total length of this side is 10 centimeters, the remaining part here is equivalent to 7 centimeters. Now let us use our original figure earlier. So let's cut it this way. Again, I have here a square and a rectangle. Okay, this is 3 centimeters and this is 2 centimeters. So to find for the area of the rectangle, we will have 10 centimeters times 2 centimeters. That is equivalent to 20 square centimeters. And for the area of the square, we have s squared, which is 3 centimeters squared. And that's equivalent to 9 square centimeters. Adding these areas will give us 29 square centimeters. So the area of this composite figure here is equal to 29 square centimeters. For our last example, let's find for the area of this figure. So we have here a trapezoid and another trapezoid. Okay, so in a trapezoid, for us to find for its area, we have to add the bases, divide it by 2, then multiply it by the height. So let's start with the smaller trapezoid. Since there is no unit given, we will only use units. Okay, so we have 5 units plus 10 units divided by 2 times 5 units. And that will give us 15 units divided by 2 times 5 units, which is equal to 7.5 units times 5 units. And that is 37.5 square units. For the bigger trapezoid, we have 10 units plus 14 units divided by 2 times 8 units. And that is equal to 24 units divided by 2 times 8 units. So all in all, we have 12 units times 8 units, which is equal to 96 square units. Adding the area of the smaller trapezoid and the bigger trapezoid, we'll have 133.5 square units. So the area of this composite figure here is 133.5 square units. And that's all for our lesson for today. Thank you for listening.